Alright, so I adjusted the code. I reset everything. I put a new drill bit in. Let me try to get that focused where I need it to be. Alright, so I'm retracting this a lot more. It's going to take me another 2 minutes to do the thing, but it's going to give me a chance to just do an air blast and just make sure I clear the chips as I'm drilling with this very tiny drill, because it's also not just tiny, it's also fairly expensive because it's carbide and it's so tiny like that. So I'm set up, ready to do an actual run. Let's see what we got. Fix that. That's good. Into our first tool change. Got it moving. Piece there, it's flying around. See if you got this. Okay. Significantly better, no chatter on that. The WD-40 spritz. Okay. Alright, here's the one that broke last time. I got it. Final peck. Hope we can get this clean. Okay. A bird's nest, damn it. So I caught a bird's nest, but we got the part out. I didn't like the bird's nest ruined my finish there, but the rest of it looks really good. Let me pull the glove off. Alright, let me run one more, and then I'll see if they're staying where I want them to. See some things I can improve still on the code, but Better finish, but getting a little chatter. Might have chipped that diamond insert, unfortunately, when I did that first run. So I'm getting a little chatter on the face there. Or I just gotta do that finishing pass a little faster. Feels great, but I do have a little bit of chatter I can visibly see that I want to try to get rid of. I don't know if it even picks up in the camera, but I can see it. I think I can make that even cleaner. Like up here is beautiful, so that worked out great. I gotta work on my speed and feed there. But nice. Yep. I don't like that surface finish. That's supposed to be diamond-like coated end mill, but it is an Amazon special. So I think that finish looks kind of like shit. So I'm going to probably switch that out with just a traditional carbide end mill. Like a quality brand, not an Amazon special on that. Everything else is, well, I mean, my diamond insert is not a quality brand. That's a Pinnacle off of eBay. But the rest of it's like quality carbide minus the two diamond-like coated unicorn snot looking things. Yeah, just minus that rough spot there. That looks really good. Yeah, it's really nice, even though it's a little chattery. I'm going to probably just run the finish pass at a feed rate of 6 inches per minute instead of 4, like I set it down to. But I think 4 is perfect up here. Those look amazing. That slot looks amazing. These look great. I'm going to tweak this in a little more. There's some things I want to do to improve it. But this is video 1 of lightweight, high pressure Mini Reg Pistons that I'm planning on developing into a product, hopefully. Alright, this is Andrew at FloryPB, and that's it for this one. Thank you. Alright, so this is the part we're trying to make. It's going to be cut this way, and it's going to be a little different than this, especially because it's going to be aluminum, and I'll explain in a future video why I'm doing it that way. But let's do an air cut, double check, make sure my code looks okay, and then we'll try to do a cut. We had a screw up there, and I think that was my fault. I think that was my fault. I thought I had the right G-code to set my Y-axis, which is going to be my tool change number, but I got to manually set it back to 1 in the beginning. Let's try this again. Change to tool 3. All right, let's give this a shot then. That looked okay. Zero. Right. Let's put that back to 1. Make sure my offset's right. All right, we're gonna give this a shot. See if we can run one. That's not what I wanted to do, so I gotta change that part in the code. Gotta get rid of this delay here that I have. Change the speed on that one. That was brutal. Dang. Alright, so I ruined one of my 2mm, my little drill bit, so I gotta do that a little differently. I gotta retract that harder. Nice if I could find it. So I gotta figure out what I did there. I screwed that one up, but that's okay. That looks really nice. I need to change my tool set up here, I think. That was not happy about that. I'm not happy with how that looks. Don't mind that finish. That really stinks about the this drill bit getting stuck in there. I gotta retract it harder, I guess, between them. So I'll do that to try to clear a little more chips off of that. The part feels pretty good though. Like, I like my surface finish on a lot of stuff. Obviously I have to change that initial the cut up this way. That's not what I want to do. And I gotta change whatever the hell I did there. That was messed up. So I'll make some adjustments to the code, and I'll get another 2mm insert in there. So it looks good. Everything else looked pretty okay. I might switch my two end mills around, because that ain't worth it, whatever that just did there for that little chamfer in there. That's all chowdery. Not worth it, so I'll figure that part out, and I'll be back with a second attempt at this. So this would be the part that we are trying to make. This is made in Inventor, and we have our internal features, and then the external features that we have to do. A couple O-ring glands to cut as well. And basically the way that I made this G-code, I could have done this in Fusion or Inventor for its own right and generated or made toolpaths and you know, use the CAM aspect of it, but this is still a fairly simple part. It's lathe work, so most lathe work is fairly simple. So what I end up doing is I just take a cross section of it and I bring it into CAD, and then I kind of just draw my tools. Like this would be my parting tool that I'm going to use to do most of my facing and my all my cutting, and then I can figure out how big the stock is. I set my X0, I set my Z0, and I just kind of bring this along and measure off of it. And this is a 2-screen affair, but so I can only show you one. And I just kind of build my G-code based on that, just hand done G-code. I did use ChatGPT just to do the drill pack order, so I didn't have to do that multiple times. But it's a fairly simple G-code. The only thing I'm trying to do, which is a little different, is this part. I think traditionally the way I would tackle this is I would do this section first, this long skinny section first, and then part it off here, and then I would switch from my three-jaw chuck to a collet chuck setup and slip this back end into the collet chuck, and then do this top portion and drill all the holes through it, or most of the holes through it. But I have this feeling, or I was trying to, really I was trying to use my live center, but I realized that my tailstock on that lathe is way out, and I can't really fix it because it's out vertically. So that's going to be a big project to get that dialed in. But my thought was I was going to use my live center, and I was going to cut it from the big end down to the small end, which I still think I can do. So basically this would be my parting tool. I'd be coming in, I'd be hitting all of this, I'd be bringing it down to close to dimension on the big end. Then I'm going to be switching over to my drill bits. This is my 1/4" stuff. I lost my 2mm, my 4.2mm drill bit, but I can bring these in and do my PEX cycles. This would be my 1/4" end mill that I'm using as a boring bar. I'm going to cut this. I'm going to cut all of this with this tool. And then once I do all the internal work, after I do the big end, do the internal work, I'll finish the big end, then I'll part down and do the small end. I might have to adjust this, and I might have to do this finish cut prior to doing this work. So I'm going to see if I can get away with how I had it with the live center in there in my G-code. If not, I'm going to have to change this to be do the big work, do the internal work, do this section, get that finished, just because every time I'm coming further to the left here, I'm getting closer to my chuck, closer to the fixture point. So your cantilever is smaller on the part every time you get closer to that chuck. That's why it's really nice to have the second live centering, because then you're simply supported at both ends instead of or a little better than simply supported, but you have a fixity here and then you have a fixity here, so you're double fixed.
not single, but I'm going to come through, do all this stuff, and then do the final part off. And the reason I'm doing it this way is because the only thing I have to do as a second op is I have to put in this tiny chamfer here as a second operation, but this chamfer is not exactly critical. I can probably just do that by hand with a deburring tool. It would actually be better if I probably did with a little deburring tool. It's a very tiny chamfer. So if I can get away with it, I'm going to try to do it this end first and cut down to this small end. And we'll see how it goes.